Now, here we have introduced something new, a heterogeneous equilibria. And so what we have in this case, in a heterogeneous equilibria, it occurs when the reactants or products in the equilibrium are in different phases. So in the past, we've seen that the reactants and products all have the same phase, right? Well, here, we don't have that. We have aqueous, 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 and then we have liquid water there, water being the solvent. So these are not all in the same phase. So when I write the equilibrium constant expression, in this case, how do I write it? Well, if you looked at the notes very carefully, you notice that for a specific reason, the concentrations of solids and liquids do not appear in the equilibrium expression. So as long as there's some solid there, it's omitted from the equilibrium expression. In this case, water being the solvent is present in such a larger amount than these solutes that the concentration of water as it's involved in this reaction doesn't really change at all, so it's treated as a constant. Those are the rough explanations there. But the book also discusses it in detail. So the main idea is that for heterogeneous equilibrium, I'm going to write the plural, equilibria, omit solids and liquids. Omit solids and liquids from the equilibrium constant expression. Okay? So we're going to omit solids and liquids, not include them. So what do we have here? I've got liquid right there. Tells me that it's going to be omitted from the equilibrium constant expression. It's going to be treated as a constant and just omitted altogether. Okay? So how am I going to write this? Am I going to use Kp or Kc? Well, I would default to Kc for this reaction. Why? Because these would be measured as molar concentrations, right? We don't have any gases here. So Kc is equal to the concentration of our product here, cyanide. I take the concentration of cyanide, Cn. There's no coefficient there, so it stays 1, divided by the concentration of hydrogen cyanide times the concentration of hydroxide. And that's it. Notice again, we omitted water here from the equilibrium constant expression because of its liquid state. So solids and liquids are omitted.